Already we have seen some problems on time domain analysis. Now let us see few more examples. A servo mechanism is used to control the angular position theta naught of a mass through a command signal theta I. A servo mechanism means a mechanical system used to control. Servo mechanism is used to control an angular position theta naught. Therefore, theta naught is the output of a mass through a command signal. Input is theta I through a command signal. Command signal means input. The moment of inertia of load is 200 kg meter square. The moment of inertia J means S square. And the motor torque at load is, motor torque is, that is the output of motor. The output of the motor is, the mechanical system output is 6.8, that is kT. K. The gain K is given. Gain K is given. The damping torque coefficient. What is damping torque coefficient? B. B. That is 5 into 10 power 3. Bs. So this is the mathematical model given. This is the mathematical model given. What and all given? The moment of inertia J equal to 200 kg meter square. And the motor torque K equal to torque at load equal to 6.88 into 10 power 4 Newton meter radian per meter per radian. And damping coefficient B equal to 5 10 power 3 Newton meter per radian per second. What is the mechanical system? Mechanical system will consist of J, K, and B. This is K. This K is gain, static gain, not spring constant K. Spring constant Ks. There are 3 constants will be there in mechanical system. Mechanical rotational system. J, K, and B. Or JBK. JBK. For spring, for motor, the spring constant is 0. You should remember that for a motor, spring, for a motor, the Ks is 0. Therefore, the mathematical model is K upon J. This K is static gain. K upon S square plus BS. So here K, J, B are given. Ks is 0. Ks is 0. For spring constant is 0 for a motor. So these 3 are given. What is asked? Find the time response for a step input of 1 radian. Step input theta I is given. Theta I equal to 1 upon S. If theta I of S equal to theta I of S. Theta I of S equal to 1 upon S. Because it is step input. Step input means always 1. Unit step input. A step input of 1 radian means 1 by S. That is given. For that, we have to find the response. Again, let us read the question. A servo mechanism is used to control angular position of a mass through a command signal theta I. The moment of inertia of load is 200 kg meter square. And the motor torque at load is 6.88 into 10 power 4 Newton per meter per radians of error. The damping torque coefficient is, that is B equal to 5 into 10 power 3. Find the time response. It is not neither nor mentioned about open loop or closed loop. How to find the given transfer function is open loop transfer function or closed loop transfer function. This is the mathematical model of the system. Feedback is different. Feedback is different. It is not part of, sometimes it is part of system. Most of the time it is out of system. So system is given, therefore it is open loop. But where it is mentioned that it is closed loop system, it is mentioned. It is mentioned that a servo mechanism is used. A servo mechanism means a feedback system. Servo mechanism means what? Feedback system. So the open loop transfer function is given. G of S is given. G of S equal to K upon JS square plus BS. That is equal to 6.88 into 10 power 4 upon J equal to 200 S square plus 5 10 power 3. This is given. This is given. Open loop transfer function is given. But the system is closed loop. Servo mechanism means closed loop. Servo mechanism means closed loop. Servo mechanism means there will be a reference will be there. The system will be here. There is a feedback. That is the meaning. Servo mechanism means a feedback system. G of S is given. Now we have to find the C of S. Therefore, we have to find the closed loop transfer function. Open loop transfer function is given. It is unity feedback system. Unity feedback system. We have to find the closed loop transfer function. T of S equal to, numerator will be as such, 6.88 into 10 power 4 upon, denominator is sum of numerator and denominator. Therefore, 200 S square plus 5 10 power 3 S plus 6.88 10 power 4. This is the transfer function. That is equal to, if we take 10 power 4 out, what you will get? This becomes, what you will get? 6.88 upon 200 divided by 10 power minus 4. 200 into 10 power minus 4 plus 5 10 power minus 1 S plus 6.88. That is equal to 6.88 upon 200 multiplied by 10 power minus 4.02 S square. 0.5 S plus 6.88, or you can write 6.88 upon 0.02 S square plus 0.5 upon 0.02 plus 6.88 upon 0.02. Find the final transfer function in natural frequency form. Natural frequency form. For that, we know the formula. If it is underdamped, check whether it is underdamped or not. For that, we have to find the roots. Find the roots. Find the roots. (344.25) that is equal to 344 upon S square plus 25S plus 344. This is the final transfer function. Find the roots. Find the roots. Check whether zeta. Instead of finding roots, here what is asked? Find the time response. That's all. No need to find the roots. What is the value of zeta? We have to check. What is the value of zeta? For that, we have to compare this standard transfer function. What is standard transfer function? Omega n square upon S square plus 2 zeta omega n S plus omega n square. No need to find the roots. Compare this with the 344 upon S square plus 25S plus 344. Here, omega n equal to square root of 344. 2 zeta omega n equal to 25. Therefore, zeta equal to 25 upon 2 square root of 344 equal to how much? Find 25 upon 2 divided by square root of 344. How much? Huh? Zeta? Omega how much? 18.54. Omega n also we required. Omega n equal to 18.54755. Zeta equal to 0.67. Zeta is less than 1. This is zeta is less than 1. Zeta is less than 1. We know for underdamped system. No need to find the roots. We know C of t equal to what? C of t equal to 1 minus e power minus zeta omega n t upon square root of 1 minus zeta square sine omega dt plus 5. Substitute the values 1 minus e power minus 0.67 omega n equal to what? 18.55 square root of 1 minus 0.67 square sine omega dt plus 5, where omega d equal to omega n, that is 18.55 square root of 1 minus 0.67 square, that is omega d. What is phi? Phi equal to tan inverse of square root of 1 minus zeta square, that is 0.67 square upon 0.67. That's all. If it is less than 1, we can apply the formula and we can write the final result. So what are the important points here? Servo mechanism means closed loop system. The given system is a motor, that's why K equal to, the spring constant is 0. Therefore, the open loop transfer function is K upon Js square plus Bs. K is 0. Ks is 0. Here, the numerator K is called static gain.